हेलो फ्रेंड, वेलकम टू द शेलरशिप। आज हम बात करेंगे और सॉल्व करेंगे ड्राफ्ट सर्वे न्यूमेरिकल्स अचीवमेंट फेज़ 1 के। तो ड्राफ्ट सर्वे कैलकुलेशन करने से पहले, क्योंकि ये फिक्स क्वेश्चन है एग्ज़ाम में और ये 30 मार्क्स का आता है, एंड इफ़ वन इज़ ड्राफ्ट सर्वे कैलकुलेशन, वन इज़ टैंकर कैलकुलेशन, इफ़ यू सॉल्व दिस टू क्वेश्चन एंड योर आंसर इज़ करेक्ट, so that means your chances of passing is more. So today a lot of group they are asking me how to solve the draft survey numericals. So let's discuss, so that the students who are appearing in the April 2023 they will clear. So draft survey numericals, before starting we know some term, we should know some the stresses on vessels, we should learn some formulas so that we can approach the question, and if the question is twisted in the exam, so we can understand how we will approach and how we will tackle this type of question. Okay, so first you understand hog and sag. This is very important because some numericals they will give the hog and sag. The sag, that means loaded more in midship, okay, and less cargo in the forward and aft. And in hog we are loaded more on the forward and aft and less cargo in the midship. So this you should know and you should learn, and you should memorize this, because they will ask in the exam, in the question. I will discuss some 4 or 5 questions in which we generally use sag and hog. So by the diagram you understand hog load more in midship direction, you can see the by figure, and hog less in the midship directions. So before approaching the questions, we should learn what formula we are using in the draft survey calculation, and how we'll approach. So you know, this is a aft perpendicular, this is forward perpendicular, and we use in the forward perpendicular, aft perpendicular, midship draft, then forward draft mark, aft draft mark, midship draft mark. We are all going to use this all. And the summer water load line we are going to use in this ambient ship particulars, because we are getting all the LCF value, MCTC value from that. So forward perpendicular, aft perpendicular, and distance between them is length between the perpendicular. You should know. You should also know the LCF, and we are going to use in MCTC. Whatever we are going to calculate the displacement, basically is starting from the because we are going to use ambient ship particulars, so it is given in seawater density. Okay, so what is the use of draft survey? As you know that in tankers we have the ullage, we have the soundings, so we can figure out the how much cargo we load or discharge. In containers we know that how much containers away, how much containers on board. But in bulk carrier, in the bulk we are loading, so all the cargo quantities depend upon the how much draft is there. So there is initial draft survey, intermediate draft survey, and the final draft survey. All the bill of lading, met receipt is depend upon the final draft survey. So this draft survey is for bulk carrier. So before approaching the question, we should understand the question, what asked in the question, and then we figure out, we make one diagram. The diagram is very important for the understanding view and for the examination view, so that if the examiner know that you understand the question, you make perfect diagram. And if you in the end of the something is make mistake, then it will be slight mistake and you will get the step markings. Okay, so there is 4 or 5 formulas we should learn, and we will solve some questions, so you will maybe memorize all these formulas. Okay, so before approaching the question, we should make the diagrams. I will teach you how to make diagram. Then we have to calculate the main draft, initial trim, Now find forward, aft and mid draft correction. And to find the forward, aft, mid draft correction, we have the formula trim between draft mark into distance if we are calculating forward draft correction, then the distance between forward perpendicular and forward draft correction draft mark, and divide by distance between forward and aft draft mark. Same is aft draft correction and mid draft correction. After getting this all three forward, aft, midship, we will calculate the draft at forward perpendicular, aft perpendicular and mid draft correction. And the formula is forward, aft, mid draft plus minus forward, aft, draft, mid correction, which we are calculating here. Then positive, how we know that draft at a forward perpendicular is equal to plus or minus. So if the draft mark opposite to trim end, then it should be plus, otherwise it will be minus. So don't worry about this, I will teach you in the questions, so nothing to worry about. Then after we will calculate the mean of mean draft. The formula is forward, which is represent F, plus aft plus 6 midship divided by 8. This formula you should memorize. Then whatever you will get the value of mean of means draft, you will calculate the LCF from the ambihenships particulars. Okay, then we have to then this first trim correction, this is also very important formula you should remember. The first trim correction is equal to trim into LBP. So LBP is constant because we are using ambihenships particulars, so 143.16 our LBP. So you should remember this LBP, so otherwise you need to go to check the ambihenships particulars. So 143.16. so first trim correction is equal to trim into LBP divide by 2 minus LCF divide by LBP. Then you will calculate true mean draft. True mean draft is equal to means of means draft plus minus first trim correction. If your first trim correction is positive, then it should be positive. If your first trim correction is negative, then you use negative signs. Then you whatever true mean draft you will calculate, then you have to calculate the displacement in this ambihenships particulars. The whatever displacement you will get, that is in seawater. Now whatever you have means of means draft, plus 0.5 meter minus 0.5 meter minus 0.50 is MCTC1 plus 0.50 is MCTC2. You calculate, then you apply this in the second trim correction formula. So second trim correction formula is 50 into trim square into MCTC1 minus MCTC2 divided by LBP. Okay, so you know how to calculate MCTC1, MCTC2. I will solve in the numericals so you can easily understand. If in your question the list is also given, so we have to calculate list also. So formula of list is equal to 6 bracket D1 minus D1 difference between D2. So D1 is used, like if D1 is port side and D2 is starboard side. So TPC1 is from port side and TPC2 is starboard side draft. Then total displacement in seawater is equal to displacement in true mean draft plus second trim correction plus list correction. All you will get the final displacement, and then whatever you have the in numericals plus minus, and if the changing the density, change the density, and you will get the formulas. So hope you understand this formula point. Now we will solve the first question. Okay, so let's solve the first question. The first question is ambihenships arrived port for a part discharge at the following draft. Forward port side is 8.8, forward starboard side is 8.92 meter, mid port is 8.96 meter, mid starboard is 9.16 meter, aft port is 9.24, aft starboard is 9.36 meter. Density is given is 1.018. During her port stay, she consumed 20 tons of fresh water and 7 tons of diesel oil. She received 600 tons of heavy oil. She sailed from port with the draft forward. The sailing draft is 6 meter forward and aft, and 6.05 is mid. So more cargo is loaded in the mid deck. Calculate the quantity of cargo discharged at the port if the forward draft mark 2 meter forward of forward perpendicular, aft mark 3 meter aft of perpendicular, and mid draft are 2 meter forward of the midship. So let's solve this question. So I told you before, to solve any question we have to make the diagram. So let's see. So for example, this is our vessel. Okay, so this is our forward perpendicular, this is our aft perpendicular. Distance between this is LBP, length between perpendicular, which is 143.16, correct, meter. Now in question it is given, if the forward draft 2 meter forward of forward perpendicular, 2 meter forward of forward perpendicular, so यहाँ से 2 मीटर है, so ये है 2 मीटर. Okay, aft mark are 3 meter aft of perpendicular, 3 meter aft of up, so this 3 meter, so ये है aft draft mark और ये है forward draft mark. ओके, सो अभी इसके डिस्टेंस बीच का हमको डिस्टेंस कैलकुलेट करना है. सो ये से यहाँ तक 143.16 है, यहाँ से यहाँ तक 143.16 है, तो यहाँ पे 2 प्लस ऐड हो जाएगा और यहाँ पे 3 प्लस ऐड हो जाएगा, तो टोटल कितना हो जाएगा 148.16 मीटर. ओके, और मिडशिप, यहाँ पे मिडशिप है, इफ़ यू कंसीडर दिस इज मिडशिप, तो मिडशिप में 2 मीटर फॉरवर्ड ऑफ मिडशिप, सो यहाँ से 2 मीटर फॉरवर्ड है मिड ड्राफ्ट मार्क. ओके, सो लेट्स सी हाउ विल अप्रोच. नाउ so we have forward port side, forward starboard side, 8.88 meter, 8.92 meters is given here. Okay, aft port side, aft starboard side, 9.25 meter, 9.36 meter, and mid port 8.96, mid starboard 9.16. So we calculate all the forward, aft and midship main draft. Okay, so main draft. So how you calculate 8.82, 8.92. So you have to add and divide by 2. Okay, so you will get 8.90, aft you will get 9.30, mid you will get 9.06 meter. So you understand this much. Now this is forward, this is aft. So now our trim is 0.40 meter by stern. Now we will calculate forward draft correction. So formula is forward draft correction is trim between the draft marks. So our trim is 0.4. So trim between draft mark into distance between forward perpendicular and forward draft mark divide by distance between forward and aft draft mark. ओके, सो फॉरवर्ड ड्राफ्ट करेक्शन कितना हो गया आपका? आवर ट्रिम इज 0.4 as we calculated here, 0.4 into, so in the numericals, in the diagram we see it is 2 meter. Okay, so into 2 divide by 148.16 is equal to 0.005 meter. Same draft correction, same formula, only we need to check draft. So trim between draft mark, so 0.40 divide by 148.16 into 3 is equal to 0.008 meter. Mid draft correction, 0.4 into 2 divided by 148.16 goes to 0.005 meters. So hope you understand this much. Let's move on the forward. Now we'll calculate draft at forward perpendicular. So draft at forward perpendicular is formula is draft at forward draft mark. Draft at forward draft mark plus minus forward draft correction. So forward draft is how much? 8.9, see 8.90 and 8.90 plus, since it is a forward of forward perpendicular and our trim is bistern, so in that case we have the plus. Okay, so 0.005 is your 8.905 is for draft at forward perpendicular. Same draft at aft perpendicular, so draft at aft draft mark plus minus aft draft correction. So our trim by stern and the aft perpendicular is 3 meter aft of the aft perpendicular. So 9.30 minus 0.008 is equal to 9.292, and draft at midship, so it is also ahead of the midship, and we have the trim by stern, so it will become positive. So 9.06 plus 0.005 is equal to 9.065, and we have the trim between the draft aft perpendicular draft at forward perpendicular is 0.387 meters. Now we have to calculate mains draft. So formula is forward plus aft plus 6 into midship divided by 8. So forward draft is 8.905 plus 9.292 plus 6 into 9.065 divided by 8. So you will get 9.073 meters. Now for this we have to calculate LCF from the ambient particulars. So you will calculate and you will get 69.711 meters. So now we will get LCF. Now we will apply in the first trim correction. So first trim correction is equal to trim into LBP divided by 2 minus LCF divided by LBP. So put the value 0.387 into 71.58 minus 69.711 divided by 143.16. So you will get 0.005 values. So this is first stream correction value. Now we'll calculate true main draft. True main draft is equal to main or mains draft plus minus first stream correction. So since it is positive, so we'll apply positive. Okay. So our means of mains draft is 9.073 plus 0.005. So we'll get our value is 9.078. And now we get calculate this is displacement, which is 19241.66 ton in seawater. In the question we have 1.01 density. Now we will, after that we will change the density also. Now we'll calculate MCTC1, MCTC2. So how MCTC mean or main draft is 9.073 minus 0.5. So 8.573 meters. 8.573 plus 1. Okay. Or 9.073 plus 0.5. Okay. So 9.573. Now we again go in the hydrostatic particulars and we calculate. We get the figure 205.6 T and 219.9. We get the difference between them is 14.3. That is MCTC 1 and MCTC 2. Understand this much? Now let's move forward. Now we'll get calculate second trim correction. The second trim correction formula क्या है 50 इंटू ट्रिम का स्क्वायर, फिर ये जो हमने MCTC1 MCTC2 निकाला है इसको वैल्यू लिखेंगे और डिवाइड बाय LBP. So put the value in the formula 50 into 0.387 का स्क्वायर into 14.3 divided by 143.16. So we'll get 0.7 tons. In the question we have the up midship port, midship starboard, so we have the list correction also. So we'll apply list correction. So list correction का formula क्या है 6 into D1 D2 TPC1 is for D1 and TPC2 is for D2. Okay. So 6 is constant, and if we calculate 9.24 minus 9.36, so we'll get 0.2 into TPC1 1 and 2 के बीच का difference है 0.12. So we'll get 0.12, hardly any difference. So now we'll get total displacement. Total displacement क्या आता है कि जो हम हमारा इनिशियल आया था, इनिशियल ट्रू मीन ड्राफ्ट का डिस्प्लेसमेंट, now we'll calculate true displacement. So true main draft का displacement plus second trim correction का displacement plus list correction, ये तीनों को मिला के हमको total displacement आएगा. Okay, so our is 19241.6 plus second trim correction 0.7 plus 0.1. So total we get the value in 19242.4 ton in seawater. Now question we are given the different density. So now we calculate this figure in the different density. So equivalent weight in relative density 1.018 is equal to 19242.4 into 1.018 divided by 1.025. So we get the value 19111.0 tons. Okay, this is first part of numericals clear. Now सेलिंग. अब क्वेश्चन में सेलिंग्स दिया है. सेलिंग्स में ड्राफ्ट दिया है. फॉरवर्ड ड्राफ्ट दिया है 6 मीटर, आप ड्राफ्ट दिया है 6 मीटर, मिड ड्राफ्ट दिया है 6.05 मीटर्स. ओके, सो फर्स्ट पार्ट में हम मीन्स ऑफ मेन ड्राफ्ट निकालेंगे, फर्स्ट टाइम करेक्शन निकालेंगे, सेकेंड टाइम करेक्शन निकालेंगे. बट सेलिंग में हम सिर्फ मीन्स ऑफ मेन ड्राफ्ट निकालेंगे. तो मीन ऑफ मेन्स ड्राफ्ट. तो इसका फार्मूला कांस्टेंट है, ये फार्मूला हमको याद रखना है. फॉरवर्ड प्लस आफ्ट प्लस 6 मिडशिप डिवाइड बाई 8. सो पुट द वैल्यू 6 प्लस 6 प्लस 6 06.05 डिवाइड बाई 8. So we get the value 6.038 meters. This is our sailing draft. So at even keel draft पे हो सेल कर रहा है. at even keel draft is equal to hydrostatic draft. So अभी इसका हमें एमवी हैंडशिप पर्टिकुलर से इसका डिस्प्लेसमेंट निकालना है. तो 12103.9 टन इसका डिस्प्लेसमेंट आ गया. अब हमारा डेंसिटी चेंज हो रहा है, तो इसको हम इक्विवेलेंट करेंगे जो डेंसिटी हमें दिया हुआ है. इक्विवेलेंट वेट इन डेंसिटी 1.018 में. सो 12103.9 इंटू 1.018 डिवाइड बाई 1.025 एंड वी गेट द वैल्यू 12021.2 tons. Okay, this part is clear. Now we'll move to further the final part of the numericals. So arrival as we calculate initial 19111.0 tons. Now diesel oil and fuel oil consumed during port stay is minus 27 ton. हैवी ऑयल रिसीव किया तो प्लस हो जाएगा 600 टन. ओके, सो टोटल आ गया हमारा 19684.0 टन. बस ये फिगर जो है अब इस फिगर से हम माइनस करेंगे. ओके, सो मैक्सिमम कार्गो. सो क्वेश्चन में पूछा है कि कैलकुलेट द क्वांटिटी ऑफ कार्गो डिस्चार्ज एट द पोर्ट. सो मैक्सिमम कार्गो क्वांटिटी डिस्चार्ज एट पोर्ट इक्वल टू 12021.2 माइनस 19684.0 टन इक्वल टू 7662.8 टन्स. सो दिस इज आवर आंसर. सो दिस hope you understand this numericals. It's very simple. You just remember the basic 3/4 formulas and the procedure how I did. I will solve other numericals in the different types of numericals in the second part of the videos. So there is total 9 or 10 type of different questions. If you solve this all, you will be solve any type of numerical in the examinations. So guys, hope you understand this draft survey numericals. Wish you all the best for your exams, and if you have any doubt, write me in the comment box. See you in the next video. Thank you.